new chapter, that is body, because our body is mainly made up of these molecules. So a living system, it grows and sustains and reproduces itself. As you know, we grow, we sustain ourselves, and we reproduce our little ones. The most amazing thing about a living system is that it is composed of non-living atoms and molecules. And the pursuit of knowledge of what goes chemically within a living system. Okay, what are the chemical features or what are the chemical reactions that occurs in our body? Okay, is basically falls under a section called as biochemistry. Now, living systems are made up of various complex biomolecules. Okay, so a living system, it is made up of various complex biomolecules like carbohydrates. I hope all have heard about these terms, right? Carbohydrates, proteins, nucleic acids, lipids, etc. The proteins and carbohydrates are essential constituents of our food. Okay, our food basically contains proteins and carbohydrates. Now, these are biomolecules. Okay, these biomolecules interact with each other and constitute to the molecular logic of life processes. Okay, and these molecules, they are the ones which interact with each other and has various processes in our body. So in addition, some simple molecules like vitamins and mineral salts also play important role and function in the living organism. Now, in this chapter, biomolecules, basically we'll learn about their structures and functions of some of such biomolecules. So first, we'll start with carbohydrates. Okay, so our first molecule is a carbohydrate. Carbohydrates are primarily produced by plants and form very large group of naturally occurring organic compounds. Now, carbohydrates, they are primarily produced. Okay, their primary producers are plants and then have a various large group of naturally occurring organic compounds. Now, some common examples of carbohydrates are cane sugar, glucose, starch, and etc. Okay. Now, glucose, you know, I told you that it is a primary producers of carbohydrates are plants. And then if we have an example of glucose. So where glucose is produced, there is one process that happens in plants, that is photosynthesis. Okay. In photosynthesis, what happens? It takes carbon dioxide and water, right? And what it is produced? We get something called as C6H12 and O6. This C6H12O6 is a glucose molecule. Okay, so this is how plant are their primary producers. Okay, most of them have a general formula of CxH2O. Okay, H2O. This is a general formula, that is CxH2O. Now here glucose also same thing you can observe. C6H2O. H2O, here they have given a even number, but when we combine and give them a complete number, it is like this only, H2Y. And we were considered as hydrates of carbon. So these are considered to be hydrates of carbon, from where the name carbohydrates was derived. Okay. So these are known as hydrates of carbon. And since it is hydrates of carbon, hence the name carbohydrates. Okay. Now, for example, the molecular formula of glucose, as I told you, molecular formula of glucose is C6H12O6. I have written here C6H12O6. Fits into this general formula. It can be fitted into this general formula. How? Now, CxH2O, it is right. CX, what is the C in glucose? It is C6. So, C6H2O6. Okay, because this 6 is multiplied to oxygen and hydrogen, right? 6 into 1, 6. So O6, 6 to the 12. So H12. So it is perfectly fit, right? So this is a general formula for glucose. But all the compounds which fit into this formula may not be classified as carbohydrates. Since there are some molecules which can fit into this general configuration, but they are not classified as carbohydrates. For example, acetic acid. Okay, CH3COH fits into this general formula. Okay, as C2H2O twice. Okay, this is the general formula of acetic acid. But this acetic acid is not a carbohydrate. So, not all the compounds which fit into this general formula can be considered as a carbohydrate. Similarly, rhamnose. Rhamnose is C6H12O5 is a carbohydrate but does not fit in this definition. So this C6H12O5, okay, this is a rhamnose, okay, this is a rhamnose. But this rhamnose molecule, it cannot be fitted into this carbohydrates ka general formula. But that doesn't mean that this is not a carbohydrate. This is a carbohydrate. Even though acetic acid can fit into this general formula, but it is not a carbohydrate. Whereas rhamnose, it doesn't fit into this general formula, but it is a carbohydrate. Okay. Now, a large number of their reactions are have shown that they contain specific functional groups chemically. Okay, they contain specific functional group. Okay, these carbohydrates, they contain specific functional groups. Now, chemically, the carbohydrate may be defined. Now, what is the definition of a carbohydrate on the chemical basis? Now, carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones or the compounds which produce such units on hydrolysis. Now, what are carbohydrates? They are defined as polyhydroxy. Polyhydroxy means many hydroxide group. Hydroxide is OH groups. Okay, so polyhydroxy aldehydes or ketones. What are aldehydes? Aldehydes are CHO and ketones are C double bond O. This is an aldehyde and this is a ketone. So there are carbohydrates. They are defined as polyhydroxy aldehydes or ketones or the compounds which produce such units, which produce aldehydes and ketones on hydrolysis are carbohydrates. Okay. Now, what is the definition of carbohydrates? Carbohydrates can be defined as optically active polyhydroxy aldehydes or ketones or the compounds which produce such units after hydrolysis. Some of the carbohydrates which are sweet in taste are called sugars. So sugars, basically the sugars we have, they are carbohydrates. Okay, some of them are carbohydrates and are called sugars. The most common sugar used in our homes named as sucrose, whereas the sugar present in milk is known as lactose. Carbohydrates are also called as saccharides. Okay. Now, as I told you, carbohydrates, they have a sweet taste, hence they are called sugars. And the ones which we use at home is called as sucrose, and the ones which are present in milk, okay, that is a lactose. The carbohydrates, they are also known as saccharides. Now, in Greek, saccharon means sugar. That's why it is a saccharides. The classification of carbohydrates. How carbohydrates are classified. Now, carbohydrates are classified on the basis of their behavior on hydrolysis. Now, on hydrolysis, how they behave or how they divide. On that basis, they are classified. Okay. Now, they have been broadly divided into three groups. Okay. There are three groups. First one is the monosaccharides. Now, carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehydes or ketones is called monosaccharides. Okay, what is a monosaccharide? It is a carbohydrate that cannot be hydrolyzed further. Okay, which cannot be hydrolyzed to give a simpler polyhydroxyaldehyde or ketone. It's called monosaccharide. So monosaccharide cannot be divided further. Okay, the carbohydrates which cannot be divided on hydrolysis to give aldehydes or ketones are known as monosaccharides. About 20 monosaccharides are known to occur in nature. So there are 20 monosaccharides, okay, which are identified in the nature. Some of the common examples are glucose, fructose, ribose, and etc. Glucose, you know, fructose is another form of glucose only. and there is a ribose. These are the examples of monosaccharides. The second is oligosaccharides. Now, oligosaccharides is also known as disaccharides. Okay. Now, carbohydrates that yield 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. Now, what are oligosaccharides? Oligosaccharides are the carbohydrates which on hydrolysis you can get 2 to 10 monosaccharide units. Okay. They are known as oligosaccharides. Now, they are further classified as disaccharides, trisaccharides, and tetrasaccharides, and etc. depending upon the number of monosaccharides. Since you can say they can be obtained 2 to 10 monosaccharides can be obtained from an oligosaccharide, right? So, depending upon the number of carbons, you can classify them as disaccharides, trisaccharides, tetrasaccharides, pentasaccharides, and etc. Okay, and depending upon the number of monosaccharides, you can classify them. Now, they provide on hydrolysis. Now, these are the molecules they provide on hydrolysis. Now, amongst these, the most common are disaccharides. So, most common ones are disaccharides. Okay, so the disaccharides means that you have two monosaccharide units obtained from the hydrolysis are disaccharides or maybe of same or different. Okay, disaccharides can be of same or a different formula. One will have same amount of or both the monohydrate monosaccharides will look same or they can look different also. For example, one molecule of sucrose on hydrolysis gives one molecule of glucose and one molecule of fructose. So when you hydrolyze sucrose, when sucrose is hydrolyzed, you get one molecule of glucose and one molecule of fructose. Whereas maltose gives two molecules of only glucose. Okay, so sucrose and maltose. Okay, sucrose and maltose are oligosaccharides. Okay, here sucrose it can be converted into oil. On hydrolysis, sucrose gives glucose and fructose. Those will give two molecules of glucose only. Okay, you will get two molecules of glucose. So it can be either same or it can be different. Okay. Now next is your polysaccharides. Now carbohydrates which yield a large number of monosaccharide units on hydrolysis are called polysaccharides. Poly means many. So if you get more number of monosaccharides, okay, large number of monosaccharides on hydrolysis is called polysaccharides. Now, some common examples are starch, cellulose, glycogen, gums, etc. Okay. Now, polysaccharides are not sweet in taste. Polysaccharides are not sweet, hence they are also called non-sugars. Now, the starch, cellulose, starch you can find in potatoes. Okay, so they are not sugars. They doesn't have a sweet taste. Hence, they are called non-sugars. Now, the carbohydrates may also be classified as they are as either reducing or non-reducing sugars. Now, carbohydrates they can be classified as sugars and non-sugars also, and even they can be classified as reducing or non-reducing sugars. Now, all those carbohydrates which reduce Fehling solution and Tollens reaction are referred to as reducing sugars. Now, how you will find which are reducing and which are non-reducing? Now, reducing sugars or the carbohydrates which are known as reducing sugars, they will reduce Fehling solution and Tollens reaction. Okay, if they can reduce Fehling solution and Tollens reagent, they are known as reducing sugars. And all the monosaccharides, whether aldoses or ketoses, are reducing sugars. Now, all the monosaccharides, okay, they are reducing sugars. Now, first we'll start with the monosaccharides. Okay. Now, monosaccharides are further classified on the basis of number of carbon atoms. Now, monosaccharides, they can be classified on the basis of number of carbon atoms and functional groups present on them. So monosaccharides are classified on the basis of number of carbon atoms and functional groups present on them. If a monosaccharide contains an aldehyde group, now which is the aldehyde group? Aldehyde group is C double bond O H. This is an aldehyde group. Okay. So if a monosaccharide, it contains aldehyde group, it is known as aldose. Okay, it is known as an aldose. If a monosaccharide contains aldehyde, this group, then it is known as aldose. And if it contains keto group, now what is a keto group? C double bond O. This is a keto group. Okay, if it contains keto group, then it is known as a ketose. So an aldose and ketose. Number of carbon atoms constituting the monosaccharides is also introduced in the name as in the evident form. So here are the names. So carbon, if there is a 3 carbon atom, then it is a triose. Okay, it is a triose because 3 carbon atom. If these 3 carbon atoms has a aldehyde group, then it is an aldotriose. If it has a ketose, then it is a ketotriose. So similarly for tetrose, pentose, hexose and heptose. Okay, as the number goes, the name will also, the general term will also change. And whether they have a aldehyde or a ketone, then they will have a aldo and a keto in front of their general form. Okay. First, the glucose. Okay, glucose is a hexose. Okay, glucose occurs freely in nature as well as in the combined form. So glucose, it can be free in the nature. You can only have glucose, or you can have it in a combined form with any other molecule. Now it is present in sweet fruits and honey. Now glucose is present in sweet fruits and honey. Now ripe grapes also contain glucose. Ripe grapes means the grapes which are already done growing. So they will also have glucose in large amount. Now how glucose is prepared? Okay. Now preparation of glucose, first from sucrose or the cane sugar. Now if sucrose is boiled with dilute HCl, now this is how we prepare it in laboratories. Okay. You have to boil sucrose with dilute HCl. You have to take sucrose, you have to boil it with diluted HCl. HCl is hydrochloric acid or H2SO4 in alcoholic solution. Okay. Either with a dilute HCl or H2SO4 which is in an alcoholic solution. Glucose and fructose are obtained in equal amounts. As you know, sucrose is a oligosaccharide. If you hydrolyze a sucrose, you get glucose and fructose. So same thing is done here. Now you can see this is sucrose. C12H22O11 is your sucrose. On hydrolysis with H plus ions, you get glucose and fructose. Okay, that is the one method. Now, second method is from starch. Okay, now commercially, glucose is obtained by hydrolysis of starch. If you hydrolyze starch by boiling it with dilute H2SO4 at 393 Kelvin under pressure, you get starch or cellulose you can take. You have to hydrolyze it with dilute H2SO4 at a temperature of 393 Kelvin under pressure, you get glucose. Okay. Now this is how you can prepare glucose in laboratories. So for today's class, we will stop here. For next class, we will see about the structure of glucose. So for the next video, we'll start from the structure of glucose. So in our today's video, we have seen about the biomolecules. One of the biomolecule we have started, that is carbohydrates. We have seen the classification of carbohydrates, monosaccharides we have seen. Then we have seen the glucose and the preparation of glucose. So thank you for watching my video. Please do like, share and subscribe to our channel.